Hello, and welcome to our nuclear science series on radiation and radioactivity. Over the next few videos, we will cover the fundamentals of the atom, discuss atomic and nuclear stability, what makes something radioactive, and finally talk about radiation. To start, let's talk about the atomic structure. We are used to observing the world at a macroscopic level. However, in order to understand things such as radiation, we need to look a bit closer, at the atomic level. Here, as an example, is a hydrogen atom. Atoms are the basic unit of matter. They are the smallest unit that chemical elements can be found. Atoms are comprised of a tightly bound, positively charged center known as the nucleus, surrounded by a cloud of negatively charged electrons. This positively charged nucleus, where most of the atom's mass is contained, is made up of two types of particles, protons and neutrons. Protons are subatomic particles which occur in all nuclei and hold a positive electric charge equal and opposite to electrons. Neutrons are neutrally charged subatomic particles that are about the same size and mass as a proton. Neutrons are found in all atomic nuclei except for ordinary hydrogen, which contains a single proton in the nucleus and a single electron in the electron cloud. Protons and neutrons are known as nucleons, as they are found in the nucleus of an atom. Surrounding the nucleus are electrons. Electrons are much smaller than protons and neutrons, but electrons have a negative charge, equal and opposite to a proton, as we have mentioned before. It is within the electron cloud where these fast-moving electrons can be found. The number of protons within an atom will determine what chemical element it is. As we have seen before, hydrogen atoms contain one proton in their nuclei. Looking at other elements, a helium atom will contain 2 protons, lithium will contain 3, carbon 6, and so on. Looking at electrons, the number of electrons an atom contains will determine whether or not the atom will hold a net charge. If the number of electrons is equal to the number of protons, the atom is considered neutral and carries no net charge. As an example, the helium atom shown contains 2 protons and 2 electrons. As there is no net charge, this atom is neutral. An atom that does hold a net charge is called an ion and can either have a net positive or net negative charge. If an atom contains more electrons than protons, it is known as a negative ion or an anion. For example, helium- contains 2 protons and 3 electrons, and helium-2- contains 2 protons and 4 electrons. On the other hand, if an atom contains fewer electrons than protons, it is known as a positive ion, or a cation. Looking again at helium atoms, helium+ contains 2 protons and 1 electron, and helium-2+ contains 2 protons and no electrons.